In C++, a template is a generic function or class which will be able to deal with multiple types of data. You might be familiar with overloading functions where you might have an adding function that adds together integers, but then if you wanted to add together doubles, you'd need to make a copy of it that takes double data type. If you wanted floats, you'd need a third copy of it that takes float data types. If you use a template, you'll be able to define a function that could take any of those data types and do the adding operation with it. So if we consider a linked list, for example, we might have a linked list that takes integer data, so 4, 16, 23, 55. It would be very nice if we could keep all of the same linked list functions if we wanted to put characters instead of integers, without having to completely rewrite every single one of our functions to use a character instead of an integer. So the advantages of using your templates is that it'll save you a lot of time with retyping your code, it promotes code reuse, and you're less likely to have mistakes because you don't have a lot of recopying and retyping that you're doing. There are two types of templates. One is when you have a templated function, so maybe an adding function that can take any sort of data, and the other is when you have a class, such as our linked list class, that takes multiple types of data into the class. So we'll consider functions first. When you're templating a function, this is what it will look like when you don't have it templated. This function returns the max of an int a and int b. It's making use of what's called a ternary operator as a condensed if statement. So it returns a greater than b with the ternary operator a colon b. That's equivalent to if you had wrote out this. To implement a function template onto that, there's going to be two steps. You write above the function template, so that you're starting a template, angle bracket type name. The type name is what you are going to name that template type. So the template type is whatever type of data is coming into it. The name can be pretty much anything you want. In this example, it's naming it T. So then whenever you want to use that template within the function, you replace the int, the character, the double, whatever the data type would be, with the name you entered here. So we put the T here, and this maxi I function will now return the template data type. And it will now take a template data type T called A, and the template data type B. Since the template data type can be anything as long as it matches, this function would now be able to work with integers, it would be able to work with floats, it would be able to work with doubles. So the T is just a dummy type. It's replaced by the particular data that you use when you actually invoke the function. So using a template function is very easy. You're just going to call it as if it was a regular function. So here's where we have our definition. This one's taking two integers. It'll find the maximum between those integers. This one's taking two characters. And this one's taking decimals. So if we wanted to try that, we could enter it 2 here. So the max between 10 and 15 is 15, max between k and s is s, and the max between 10.1 and 15.2 is 15.2. And just as a note, if you're using a function prototypes because you're separating out compilation, you also need to template the function prototype the same way that you had templated the function definition here. So you'll still have template, type name T, T max I, with the T dummy variable here and the T dummy variable here. Then next we have class templates. Class templating is a little bit more complicated than doing a function template because there's a lot more parts you need to change. A class template comes in handy when you're storing data in containers such as linked lists, because for each container the data type might be different, but the manipulation of the data can use the same methods. So we've already talked about how that could be very useful for doing something like a linked list. 3 things to consider when you're implementing a class template. The first is that you have to write your template type name, whatever your type is going to be here. Again, this can be pretty much anything you want it to be. This example uses t-type. It doesn't have to be t-type. It could be something else. Then when you are defining the function, you need to write that dummy t-type in here with the angle brackets before the full colons in the function definition. And lastly, whenever you use a specific instance of that object, you actually have to write what type of object it's going to be. This is not the same as the t-type here. This will be, if you're creating an integer object, you'll write integer here, int. If it was a character object, you write char, things like that. So here's an example. We have our template type name t class, named my class. It has stored a t called I. Its constructor takes a t that it's calling a. Every one of the templated functions that this class uses also has this template type name t. And it has this angle brackets t before every definition. And it's taking t type as its incoming parameters. So this is just setting the t-type I as a. And then when you start calling these constructors or that show, when you're calling the constructor specifically, you're declaring what type of data you're actually going to use in that specific object. So this one is a my class of type int. This one's a my class of type char. You don't need to change anything about these functions because they aren't instantiating anything. So you can see that the function calls will be the same. And we could try that out. If we wanted to change this to a double, we would just change out int with double. And also change out double here. Like that. So you do need to be careful about what type of data you're calling for that object to be when you're using the template.